Hello, 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 hello. Good afternoon, everyone. We'll start in few minutes. Okay, let others join.
Hello.
Yes, sir.
Can you hear me? And my screen is visible, right? Also.
Yes, sir.
Okay. 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 Thanks.
So shall we start then?
Yes, sir.
Okay, okay. So once again, good afternoon, everyone. So today is your tutorial of week 5, tutorial session. This is Rahuldev Ghorai from ISO Tiruvananthapuram. And yeah, we'll start for the week 5. Mainly, the main things we have to know about the system, linear system, how to solve linear system easily, or something like root finding numerically, so approximating the root from the how to find out the root of equation. So those things we have. I hope all of you have gone through those things. Then like if someone now, many people are not here, but we will be watching you in the YouTube. So so you should first go through the lecture notes, like lecture videos, and then try to solve these questions one by one. I'll be discussing. You can first read the questions, stop the video, and okay, 1 minute. I think someone wants to join. No, okay. So this is the first question. So you have to mainly find the solution for this system. So now one knows many way to solve this linear system, this system. So then, but we want here you to find out this solution of this system using the row operation. Okay, just pencil. So this it's written the solving a system of linear equation using row operation. So it will be easier when you will be working with big coefficient, and the coefficients are very difficult when you take many this unknowns, number of unknowns, or the coefficients are also big, and then what will happen, you have to substitute one by one, and you do that will be very difficult. But if you do it using row operation like this, let's say you have what you have here, the matrix. First, what you we write in this matrix, sorry, this system, what we write it as Ax equal to B type of form. And you know, if A is invertible, if A inverse exists, then we can easily find A inverse x equal to inverse B. But if you have a like linear system which has x thousand number of uh, unknowns, and coefficients are also very difficult to handle, then finding inverse, like doing this inverse of finding inverse of that matrix will be very difficult. So, but what one can do here, that will be also taking time, but one can, this will be much easier. What is that? So first we write this Ax equal to B form, the matrix Ax equal to B form, where, so this system, the in the question 1, this system can be written as Ax equal to B form, where what is A? You just take coefficient of this, and this one will be 4 0 minus 2, right? That is A. And what is your B then? 5 9 and 16, right? So now what we will do, we'll write this A is augmented matrix, something called augmented matrix. So nothing, that is this is a notation, and then what we write it as 1 1 4 1 3 0 1 2 minus 2. We keep and we write the column of B, that is 5 9 and 16. So before that, so let's say you have a matrix like 1 1 1 0 2 1 0 0 something 3 times this x1 x2 x3 is equal to some numbers are there. So let's say 5 6 6. So then how you solve this one? You just take the first one will be x1 plus x2 plus x3 equal to 5, x2 plus 2x2 plus x3 is equal to 6, and 3x3 is equal to 6. From here what you get, x3 is equal to 2. From here you what you will get, x3 equal to 2, then x2 will be also I think 2, then x1 is equal to 1, right? So if you have a matrix like this, some type of lower triangular, or you have more zero in the matrix, what I mean, then what will happen? You can easily solve that system. Right? This is a linear system, but this you can solve very easily than this. Let's say same thing, only some other 1 to 1 and 3 4 3 like that. So then it will be very difficult if the matrix is of the form like this. So when you have matrix which has lower triangular or very less number of non-zero entries, then you can solve it easily. So what we will do here, why I said this, we'll try to write A augmented B as in that form. So what is A augmented B? Again I will write 114 130 1 2 minus 2 and 5 9 16. Now I will change it to, I will do row operations. So you have 4 here, you have 1 here, so I'll try to make this thing 0. What will happen? So how to do that? So this is your row 1, sorry, this is row 1, this is row 2, this is row 3, right? You have your row 1, row 2, row 3 are like this, right? This is row 1, this is row 2, this is row 3. So when you do an operation, you have to do for all the things. So what we do, R2 minus R1, and when I write first R2, then I will change it in R2. So this is R1, so I keep as it is, and I do R2 minus R1. What will happen? It will be 0. This one will be 3 minus 1 is 2. So you have to subtract from here, right? So 2, and this is 1, this is 4. Again now here in R3, what I will do, R3 minus 4 R1. What will happen? This is 0, this is minus 4, this is minus 6, this is 16 minus 5 into 4 is minus 4, right? See, this is coming like as I told you, we want as many as 0 as possible, but usually you try to make it like a lower triangular type of matrix. That is much easier. Okay? But even with very less number of 0, then also you can solve. But lower triangular is very easy to solve. You can just see 1 by 1, you can just substitute it, right? Okay, so now this in the row operation, still this matrix is again it is very difficult to handle, right? A augmented B. So what we'll do is we change it to, we will again make this one 0, right? So then to do that, what we will do, R3 plus 2R2, right? What will happen, this is 1115, let it is as it is, 214, because in R2 we are not doing anything, you will do in R3, so it will be sorry, yes, R3 plus 2R2, so minus 4 plus 2R2, it will be 0, then minus 6 plus 2, it will be minus 4, minus 6 plus 2, it is minus 4, and this 4, right? So now we obtain this matrix. Now you see it is very easy to deal with, because this matrix means 0 2 1 0 0 minus 4, and x1 x2 x3 will be equal to 5 4 4. So the thing is, after the row operation, this system and the system we start with will have the same solution, because we are doing a row operation under which this property will remain same. And then what we will do, you can just easily see that minus 4 x3 will be 4, that implies x3 is equal to minus 1. And from this line, what you can show that 2x2 plus x3 is equal to 4, 2x2 plus x3 is equal to 4, that implies x2 is equal to 4 minus x3 means 4 plus 1, 5, 5 over 2, and similarly you can show that x1 will be 7 over 2. Do you understand this?
Yes, sir.
So okay, right? So this type of questions then you can do it, okay? So I think the solution also again you have given the where I wrote just solution, and the operation I wrote, so you can do it right then. So here I have explained how it is coming, and then it is much easier than if you try to solve with whatever this matrix was. So it was again use, I mean, you are doing the same thing, but in a much easier way. We don't need to consider always x1, x2, x3 and all. They are always common. You take A augmented B without x1, x2, x3 and write like this. Okay. So this is, if the matrix is, it is question 2, if the matrix is given like this, 3 by 3 matrix is strictly diagonally dominant, find possible values of alpha. What is the definition of strictly diagonally dominant matrix and why it is important? You know?
No, sir.
Yeah, but strictly diagonal dominant matrix, the definition you know, right? Or no?
AI greater than or equal to summation.
Sorry.
AI is greater than or equal to summation Aij. I is not equal to J.
Summation. Yeah, that's great. So okay, then you can solve this question. I think you solve. Then I will say about the property. It's very like interesting. So mainly there, first of all, they will be invertible, right? Strictly means they say first of all strictly mean here it will be not greater than equal to, okay? It is greater than.
Yes, sir. Yes, sir.
And then it will be, I mean, this will be in any strictly diagonal dominant matrix will be invertible. That's very important thing, right? If you have a strictly diagonal dominant matrix, then that will be invertible. There are many more things, but I felt this one is one of the very nice property. It's very important also. Whether there are very big metrics, you like don't know whether it will be invertible or not. You just check and you say that yeah, it is invertible. Yeah, you cannot say that whether it is not invertible or something, but when it is strictly diagonal, then you can say that it has a unique solution, whatever big metrics are, right? The system will have unique solution. So that's very important property it has. So also might be some positive eigenvalues and all those are later, but it will have like it will be invertible. Okay, so you can remember this. I use this property in some of my work, so that's why. If you want proof, let me know. I can maybe make a video on this. Then maybe I will put it in YouTube if you want. So otherwise, you can check any book also. You can check. It will be there hopefully. Right. So anyway, you are done with this.
Alpha less than 2.
Sorry,
Alpha less than 2, sir.
alpha is less than 2. Yeah, I think that will be the correct. So what
Sir,
you
this is the
did?
case when the given matrix is diagonally dominant by row.
Diagonally dominant mean it will, when we say diagonal dominant, it will be diagonal dominant by row also in column. If you say restricted diagonal dominant by row, then only the row. If you say it is by column, then only column. But it is here, it is not written, right? So it will be in
Yes,
both sides. It is diagonal dominant. So in that case, what will happen? Your this two is a diagonal matrix, sorry, diagonal element. So 2 has to be greater than 1 plus 0. So like that. So it is true anyway. We are not interested in this. So then we come to the diagonal element 3. 3 should be greater than alpha plus 1. That's mean alpha is less than 2. That is not still done because alpha is here also in this column also. And in this column, alpha, so 10 has to be less than alpha plus 0 also. Sorry, it needs to be greater than, right? Sorry. 10,
greater than, sir, alpha.
10 has to be greater than alpha plus 0, right? So alpha is less than 2 will be enough for both the things. So
Yes.
intersection will be, right?
Yes,
So
sir.
alpha is less than 2 is the correct answer. So this was uh, easy, but this strictly diagonal dominant matrix, I wanted to say that they are very
Invertible.
important. Sorry?
Strictly diagonally dominant matrices are invertible.
Yes.
Yes.
Yeah, that also. Also, when you will read the Gauss-Seidel iterative methods, you will see this type of matrix will always like those methods will always converge for this type of system, and you know how those methods are important. That also you know, and then this type of matrix will be convergent for those. That this type of for this type of matrix, the Gauss-Seidel iterative method will be convergent. Okay, so I gave the yeah, like you told, and then this is that's correct. So solution is given. Now question 3. Now we come to the Gauss-Seidel method. So sir, compute x1 after one iteration of the system. So if you know the initial guess x naught, then you find.
Sir, can you explain this question? Sir, only one question.
No problem. I will discuss, but you first, you know the theory, right? That's what I'm thinking. Whether I should tell theory or
Sir, I was unable to, sir, understand.
okay. Wait 1 minute. I'll just tell you the theory also.
Yes.
So mainly what we try to do, see, the thing is like same. We try to make this coefficient matrix as simpler as possible, right? That was initially also I told. Then it will be easy to deal with. So that mainly
Yes.
that is the thing, that type of thing they will do. So mainly here we will do as a iterative method. Okay. So if you have a system like ax equal to b, so always you can write this type of system as ax equal to b, where a and b will be given and x is like unknown vector. Here in this case it will be x will be x1, x2, x3, and a will be, you know how that looks like. So now when using Gauss-Seidel method, so there will be initial guess x naught, initial guess of what? It is as a solution. You do not know the solution, but you just guess a number and guess a vector, and then you do it iteratively. How? So we always
Sir,
can write
sir,
a. Sorry, tell.
sir, how to guess, sir, the initial approximation?
No, with some guess, it is will be given to you.
Yes, sir.
Yeah, that
But
things
is
are
there
there.
any process,
It
sir?
is like
Is there
a.
any, sir, is there any process to guess the initial solution, sir?
I think no. It is well given a guess. You can, like, it's a sequence. You have a sequence, right? You first, what is the you have like first guess or second guess, that will depend on the guess, of course. So depending on the guess, it will be like easily it will converse or it will be difficult to converse. Those things are there, but initial guess how you do that, I don't, that will depend on the error. I think error analysis and all. Then it will be, otherwise I don't think you have an
Okay.
easy guess of that.
Okay, sir.
Yeah. So yeah. So now when you have x naught, so which is the initial guess. So for this type of system, with the initial guess means one guess, one factor will be given to you as x naught. Okay, and then what you how the Gauss-Seidel method work. So a always you can write as L plus Q. That is not an issue. Any matrix, right? You can write as lower triangular matrix plus upper triangular matrix, right? Having that lower triangular components, this u will be strictly upper triangular component, such that L plus u will be a. Okay, or like more precisely, what you can write like this. You have a like a b c d. For a two-dimensional matrix A, B, C, D, you can write as A, C, D, which is lower triangular matrix, plus 0, 0, 0, D, which is upper triangular matrix. Strictly upper triangular matrix, this is, and this is lower triangular matrix. You can write always like this. Now, what will be Ax equal to B? That Ax equal to B will be Lx plus Ux equal to B, right? That implies Lx will be B minus Ux. So mainly Gauss-Seidel method says that, so you can solve it, it is using xk plus 1 equal to b minus u xk, where like knowing at kth stage you can guess the next stage k plus 1, right? So when you have a given x naught, you can guess x1 like this, b minus u x naught, and lx2 keep on going like b minus u, you know now x1. So first of all, from here, how you know x1? X1 will be L inverse of B minus U x naught. So we assume that inverse exists. Okay. So Gauss-Seidel method solves the left hand side of the expression this Lx equal to U minus Bx, and we write this as L inverse times this, again you write as xk plus 1 will be L inverse time B minus Ux at k. Right? So this is these are the general theory. So now what will be this x1? This is just x1. You know x naught is given. You need to find out the x1. That's all. So can you now try?
Yes, sir.
Yeah, please try. Then we will do.
Sir,
Yes.
sir, L and U are strictly, sir, upper triangular matrices.
L is upper triangular matrix. U is strictly upper triangular matrix.
Lower, strictly or only
And
triangular?
U is strictly. That's why
Okay.
0 0 D 0.
Yeah,
That
yes,
is.
please.
I think the other way should not be a problem, but yeah, that's what this one you can you keep in mind this one. Yeah, see the initial case you are talking about, right? One thing is if you have, I told it this, if it is strictly diagonal dominant matrix, then any case it will be no problem, because for so this type of theorems are there. You have to mainly go through those. So if you have strictly diagonal matrix, then this Gauss-Seidel method will converge for any initial guess you take. That won't be a problem. But otherwise, so otherwise no such like I at least I don't have any knowledge of that. If there are, otherwise I don't know whether how to take initial guess. Most probably this type of question, if, of course it won't become, but it's a good question to ask. But in exam it won't be coming like this. How to choose initial guess, I guess. So that initial guess to be given, otherwise you take maybe some if you know the solution you take maybe nearby that, otherwise no such general way I know. If I know, like if I get to know, I'll let you guys know. Okay, I'll inform you guys. Are you doing or let I should do?
Sir, trying, sir.
Okay, no problem, no problem. You try.
Sir, 6 3 minus
Yes,
6.
6 3 minus 6. Let's check here as well. 6 3 6 minus 3 3 it is saying. Let's write what is your A?
1 minus 2 minus 1. 1 1. Row wise, sir.
Not working.
First row is, sir, 1 minus 2 minus 1. Second row is 1 1 1. Third row is minus 1 1 and 1.
It's a matrix is 1 minus 2 minus 1 1 1 1 minus 1. Okay, so your lower triangular matrix will be 1 0 0
1 1 1
0
0.
0 1 1 0 y.
So lower triangle matrix, no, sir.
Yes.
So
So
1 0
the
1 1
1
0.
yes 1 0 0, right?
So you
Then
have
1
to,
1
sir, L is not, sir, strictly lower triangular.
strictly lower triangular, not strictly lower triangular mean.
Means,
I mean what? I mean it can have the diagonals also,
yes, sir.
right? That's why you cannot, but you cannot have 1 1 0. You have to have like 1 0 0 0 1 0. Sorry 1 1 0 minus 1 1
1
1.
1.
Yeah, right.
Yes, sir.
So the first row should be 1 0 0, right?
Yes, sir.
Yeah, but you were telling 1 1 0, so
Sir,
that's
I
why.
was telling second row, sir. 1 1 0.
Okay. Second row will be 1 1 0. So I don't know. Yeah. Okay. So this is let me write. So it will be 1 0 0 1 1 0 minus 1 1 1 times x1 this one x2 1 x3 1, right? This should be 3 4 6
Minus
minus that the upper triangular
0 minus
matrix.
2 minus 1.
That upper triangular matrix. 0 minus 2 minus 1.
0 0 1.
0 0 1.
0 0 0.
Right, then you have to multiply this one by inverse of this matrix. So find out, you have to find out the inverse, then you multiply by this. So okay. No, sorry. I think this is not Gauss settlement method. I think whatever I said, it is. I get confused with this Gauss Seidel and Gauss Jacobi. Most probably, whatever I told, it is Gauss Jacobi. Sorry. Let me check. Whether Gauss settlement method is this. Yeah, but this is Gauss settlement method. Whatever it is telling. I think they have done mistake. I can see it is this. Okay, but forget what it is written here. Let us do. What is the problem, right? So what is the inverse of this 1 0 0 0 1 1 0 minus 1 1 1? What will be inverse of that?
Sir, I was getting problem, sir. Sir, determinant is, sir, 1.
Yes.
And so we have to find adjoint of A, sir.
Sorry.
Sir, adjoint of transpose of adjoint of A, sir. Times determinant.
Yes. That's not a problem. So what will happen? I think it will be. You have to. This will be 1 0 0 anyway.
Yes, sir.
Right. This will be 1 0 0. Then you have to make somehow it is. Okay, 1 0 0. If I write 0 1 you have to finally find out the inverse of this, and now it is doing okay. Let me do it in the last page itself. Okay, last. What is the matrix? Tell me. You could not find out the inverse of the matrix. That's the problem.
1 1 0. Sorry, 1 0 0. First row. And second row 1 1 0. Third row minus 1 1 1.
Sorry. Let me tell me.
First
1
row is
0.
yes, sir. Second row is
Then
1 1 0. Third row is minus 1 1 1.
1 1. So adjoint is the transpose of those minor things, right? So I am finding out the adjoint. Okay, so it will be 1 0 0. I mean the transpose of that, but I am writing first because no, that is not 1 0 0, right? First, this 1, then 1 if you take, this will be 1 minus 1 0. If you take 0 0, then it will be
Minus 1.
0 minus 1, but will that be with the sign?
Minus 1, sir. With sign, sir.
0, then it will be 2 minus 2, sorry, 2. 2, right? This is when you take 0, then
Yes,
it is
sir.
right. So if you are doing correctly, then it will be then 1. So you have to do it like this way. So 1, then it will be 0. For
0,
this one,
sir.
it will be 0. This one, it will be 1.
1.
This one will be 1. This one will be
0
0.
0 1. 0 0 1.
0 0 1 is correct. Are we correct?
Yes, sir. This
So
is
then
correct.
transpose of this will be 1 0 0 minus
0,
1,
0, 1, yes, sir. 1, 0.
2, 1, 1, right? So just multiply with this and check whether it is, yeah, I think
Sir,
it will
0,
work.
0, 1, sir. Last column.
No, 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 no. Minus 1,
Last
1, 0.
column, sir.
Yes, 0, 0. Yeah, now it is okay, I think, right? This is the inverse. This is the
Yes,
inverse?
sir. Yes, sir. Yes, sir.
Yes, yes, minus 1, 0. No, but whatever the some problem is there, that's what. So if you just multiply, are you getting identity matrix? Not, you are not getting, right?
No, sir. We are getting, sir.
Are you getting?
Yes, sir.
You multiply minus 1, 1, 1 with this column. Will you get that?
Which one, sir?
If you multiply this one with this one, meaning once you have to multiply with minus 1, 1, 1 with 0, 1, 1.
Yeah, yes, sir. I think there is sign problem, sir.
Yeah, that sign up to also you have to take.
There should be, sir, minus 1, I think.
Yeah, so
8
no,
to 3,
we
sir.
have
8 to 3, sir. In the
this
transpose,
one.
sir. Yes, sir. 8 to 3, sir. Before taking the transpose.
Before taking the transpose here.
Yes,
That's
sir.
what you're doing.
Yes, sir. Minus 1. Now
This is
it is
minus
fine, sir.
1.
Yes, sir.
Then it is fine.
Yes, sir.
1, 1, 0. Yeah, yeah. Then it will be fine, I guess. 1, 1, 0. Okay. So then you have inverse. So what we will do? X1. So x1 1, x2 1, x3 1. That
L
should be there.
inverse.
1, 0, 0 minus 1, 1, 0, 2 minus 1, 1, right?
Hmm.
Times
6, 3 minus 6. Column
6,
wise. 3,
6, 3.
6, 3 minus 6.
Is it? I'll
Yes,
just check
sir.
it once. 3, 4 minus 6, right?
Sir, B minus UX 1, na, sir. UX not. We have to, sir, minus UX not, na, sir.
That I'll do. Okay, okay. In
Yes,
one
sir.
step, you are telling B minus UX, then you are multiplying L inverse.
Yeah.
Okay, that is not a problem. But UX, then did you, was that
Sir,
correct? So your
minus
solution is
B1.
not coming correct. So that's why I'm just curious.
Yes, sir.
So that's why I'm just doing each and everything. So what is U? 0 minus 2 minus 1. We'll do it. So what was the right hand side first? Tell me.
Right hand side B, sir. B,
Yes,
sir.
B.
3, 4 minus 6.
3, 4
B.
minus 6.
Yes, sir.
Yes. Minus, what was your U?
U was a 0 minus 2 minus 1. Sir, row wise. 0 minus
Sorry?
2 minus row wise, sir. 0 minus 2 minus 1.
Okay.
0, 0, 1.
0, 1.
0, 0, 0. 1,
Times
1. 1, 1, 1, sir.
initial guess 1,
Column
1.
wise.
Good. So 3, 4 minus 6 minus,
Minus 3,
yes,
1, 0. 1, 0.
0. Then what will happen? This 6,
6
3
minus
minus
6,
6
3.
minus 6
Uh,
times this matrix. Now it will come 1, 0, 0
0, 0, minus
minus,
1, 1, 0.
that will give you 6 minus 3.
Yes, sir.
12 minus 3 is 12 minus 9
9.
will be 3. 6 minus 3 3, right?
Yes, sir.
But what you were telling 6 3
So
minus 3.
minus 6, sir. Last last entry, sir, minus 6.
Last entry will be minus 6.
Yes, sir. Mine was minus 6.
But it the now you got it right. It's correct.
Yes, sir. Yes,
This is correct, right?
yes, sir.
Okay. That's what that's what I'm checking. Okay. But I don't know. It is just written here like this. But that should be the way. I mean, this is not the way. The way should
Sir,
be
my
x.
sir inverse was sir incorrect, sir. L inverse.
Ah, that's why. That's why.
Minus
It
1,
will be
sir. Yes, sir.
L inverse will be BUXK, right? Correct, right? This formula.
This is Gauss seidel, na, sir?
Yeah, this is the Gauss total. That's what Gauss total is. I started
Okay,
with
sir.
Gauss total, right?
Okay, sir.
Yeah. So yeah, that's correct. That's how you can do it. Now we do it for the Gauss-Jacobi iteration method.
So can you write this sir, formula, sir, for Gauss Jacobi iteration?
Gauss-Jacobi. This is also similar type of. I'll just give you idea. So same only.
We have
Just
to sir factorize LU, sir. Factorize A into LU, sir.
sorry.
Just like sir Gauss seidel, we have to sir uh, factorize sir the matrix in lower
Yeah,
than.
factorization only. Just precisely tell you what is that, but some difference would be there, right? Otherwise, why they write like this? So mainly you make it more easier. I mean, instead of lower triangular matrix will be like this, right? B C 0, so let's say D E F, right? Instead of that, you take diagonal matrices A 0 0 0 C 0 0 0 F, the first matrix, and
Hmm.
the other matrix, whatever the matrix will be,
Left.
let it be as it is. Then do the same thing. Same thing. Then again, same thing. You understand?
Yes, sir.
Yeah. Instead of L plus U, you do D plus D is a diagonal matrix. D plus some residual matrix. That will be. Then you do the same process. Xk plus one. Then your xk plus one will be D, which is a diagonal matrix of the given system, and then B minus the whatever the R you will get from this A equal to D plus R, that xk, where A is equal to D plus R. Done. That's all. So you now using this you do it.
Sir, what is X not here, sir?
Sorry.
Initial, what is the sir initial guess here?
Yeah, but the sorry. Here you have to find the
Gauss Jacobian iteration matrix mean the D inverse time R, whatever is coming. That's all. You
But there is no variable, sir, in G, sir. But we will get, sir, some
no, no,
variable,
no,
right?
no, no. You don't get value. D inverse time. You have to find out D inverse time R. What is D inverse and then R? That you know, right? Just multiply with that, and whatever you get, that will be the thing. You
Yes,
can
sir.
see what will be the Gauss Jacobian iteration method. That is this, right? But from here, what you can write xk plus 1. There many asking about this. So you will have d inverse b minus d inverse of r times xk. So that is nothing but some d inverse b plus minus of d inverse r, which is a matrix, times xk. So Gauss iteration matrix will be this only, right? So you mainly you
Minus
have
D inverse times R, no, sir.
minus d inverse timer, because you
Okay.
see, yeah, you do it. I'll say what is this. So d inverse b plus minus d inverse r times xk, sorry, x naught, right? Now x2 will be d inverse b plus minus of d inverse r times x1. Now x1 we put as like d inverse b plus again minus d inverse r times x naught. So what you can write, some matrix A plus this one and this one, and plus this one will be A matrix. Sorry, not A, same A. So this is B, some B matrix plus minus d inverse r whole square times x naught, right? So what you can write, always this xk, this will be type of some matrix, depends on k, but plus minus d inverse r whole to the power k times x naught. This type of, it will keep on going like this, right?
Yes, sir. Yes,
So
sir.
this d inverse minus d inverse r, this has some like this is called, this called Gauss iteration, Gauss Jacobi iteration matrix. That is nothing else. But if you have given a initial guess, then you can solve also like this. Okay.
Second, sir, option.
Second option then. Okay, I'll check it here itself. 0 minus 1 2 0 0 minus 1 2. Okay, yeah, that is correct. The solution also given. I hope you have done like this. So the Jacobian and Jacobi. This iterative iteration comes from the this xk plus 1 is equal to d inverse times b minus r xk. It comes from there. Yeah. Then this is correct. Okay. So this is something. This is nothing. Well, nothing to do. You don't need to do. You just have to tell the answer. That's all. I mean, you need to know only that Gauss Jacobian Gauss Seidel method. So these are nothing but we solve the linear system using these methods. But whether they will converge, for what guarantees uh, we have, what's the guarantee that they will converge to the solution? Mainly we try to, the aim is to find the solution of the linear system. So but whether it will converge, that is the question. So the question is answered by, like, I also once already I told that if strictly diagonal matrix, then they will converge. So strictly diagonally dominant matrix will converge for this. Uh, yeah. So this type of for this type of system, you have ax equal to b, and if you have a as strictly diagonal dominant matrix, then that will always converge. What
Yes, sir. This is
so
strictly diagonally dominant matrix, sir.
so Gauss Jacobi matrix converge. Gauss both the Gauss Jacobi and Gauss Seidel both will converge. Okay, because this is strictly diagonal dominant. The coefficient matrix is strictly diagonal dominant by row as well as columns.
Okay, need to check by both. Therefore, both Gauss-Jacobian and Gauss-Seidel method will converge for any initial guess.
Sir,
That is very important.
is this
Yes.
condition if an necessary as well as sufficient for the convergence of the
No, no, no.
solution?
There can be other metrics which also converge, like positive, definite, all types of metrics are also there. Some
So,
other type
is
of,
there any sir
but
if
very.
any condition, sir? Is there sir
Sorry,
any necessary and sufficient condition for the
I
convergence?
I don't know if it is. I don't think there they can find out some counter example where maybe you find it's very easy to find out some metrics which is like all the whatever you are asking that type of it is not invertible or many such things are not there, but still it is conversing. So I think that is difficult to say if and only if condition. But main what you know we can know that if this happens, sufficient condition you may get. The necessary condition is difficult. Yes.
Sir, what are the conditions when the given method does not converge, sir?
What are the methods?
Yeah, no, what are the conditions where the
I
sir
mean,
method is not
yeah. I mean,
converging?
if one might give a matrix which is for which it will not converge, right? That's what you are
Yes, sir.
asking.
Yes, sir.
Okay. Mm, I think that is. I don't know. Even it is there. I mean, okay. Maybe not invertible. If the it's not consistent matrix, if it has infinitely many solutions, then will it will if you have a initial guess near that, then it will converge. So if you, any matrix you take, any matrix mean not strictly diagonal dominant or something which converges. For that, if you take any that type of matrix you take first, and then take an initial guess which is much away from the solution, then it is difficult. Sometimes it might not converge also.
Sir, but how to know, sir?
Yeah, the error between the actual solution and the initial guess. That's what I'm telling. It's very large. Then it's difficult to like it might not converge also sometimes.
Sir, can you give some examples, sir, of any matrix, matlab, which is not
No, many
any,
metrics mean you.
sir,
So see
any
this.
system?
These are numerical things. So it will take maybe 100 iteration or 200. You cannot. I cannot just keep on like doing that iteration. Right? You understand this? Xk plus one. Xk plus one is equal to some matrix times xk. Let's say this type of things are you are getting right. So for after what k it will converse that you have no idea, right?
Sir, if the given system is not consistent, then we can say that the method will not
if
converge.
if it is not consistent, that's what I'm telling. If it is not consistent, then what are the thing you have, what are the possibilities? It can have no solution, or it can have infinitely many solution, I guess, right? That too.
No, sir.
So if
Consistency means there is some.
consistent, consistent mean unique solution or infinitely many solution, right?
Yes, sir. Yes, sir.
Yeah, sorry, yeah. So if it is not having unique solution,
Hmm.
then it has infinitely many solutions, that is true. But if you start with the initial, let's say you have two solutions, like let's say a and b are solution, but you have an initial guess, let's say c naught is your initial guess, right? But this, if c naught is closer to a, thus usually the iterative method will converge to a, the solution, one of the solution. It cannot converge to two solution, right? It will converge to one of the solution. If the c naught is near to b, the initial guess, the near to b, then it will converge to b. But when it is inconsistent, then most probably it won't converge, because it doesn't know the, yeah, it won't converge. So because it does not know where what is the solution, so it will just keep on diverging.
Okay, sir.
Huh.
That is one thing, yes. So that is like it won't converse. Yeah, but one more thing. For Gauss-Seidel method, Gauss-Seidel method, I will say about the Gauss-Seidel method. Where is that Gauss-Seidel method? Gauss-Seidel or your Gauss, uh, what is that? Gauss-Jacobi method. Yes, that is one very good point. Thank you for asking. I am also learning. Okay, that's right. So, what we do? We do Lxk plus 1 is equal to uh, what is that? B, right? B minus Uxk. This is for Gauss-Seidel. Also for Gauss Jacobi also there. So for first this one. So this L, to know, you know Lxk plus 1, but to know xk plus 1,
We need sir
what you
inverse of L.
exactly. So, but will that, like, this L inverse will always exist? No, right?
Yes, sir.
So that is one thing. So similarly for D xk plus 1, I
So
mean
that is
in that,
why we take sir.
sorry,
That is why we take L as sir, upper triangular matrix, not
that is
strictly upper triangular.
that is
Because then,
they took, that is their strategy, right? Not, I mean, to solve this.
yes, sir.
Yeah, so you know, if you take just very not strictly,
Hmm.
right, then it won't be, inverse won't exist again, right? In that case,
Yes, sir.
so that's
Eigenvalues will be sir zero, sir.
zero,
Then
right? So then in that
yes,
case,
sir.
it won't be. That's why they just took it. But in that case also, if one of the diagonal element is zero, then also you cannot
Yes, sir. Yes, sir.
find
This
inverse.
is nice
So that,
observation, sir. Yes,
and
sir.
this is one observation.
Yes, sir.
But yeah, one more good question, like from your question, I can make it. Like, what guarantees to I assume that L inverse exists, right? Then what is the guarantee that it will converge
Yes, sir.
for what type of matrix? That is a good question. That I cannot now answer maybe.
Yes,
But
sir.
this is one of
But we
the,
can discuss it next time, sir.
next time we will discuss maybe. But
Yes,
this
sir.
is first condition is it has to be L inverse, or the diagonal
D
element
inverse.
of the
Yes, sir.
matrix has to be non-zero.
Yes,
If
sir.
it is zero, then we cannot apply first of all this
Yes, sir.
Gauss effect. Yeah. Okay. So that was this. Mm, yeah. Question 5. No. Okay. This, yeah, again I think it's same. The eigenvalue of the Gauss-Seidel iteration matrix. You know the what is the Gauss-Seidel iteration matrix then? So that is the same. That's L inverse time. You will
Yes,
see
sir.
that's why L inverse will have all the diagonal elements are non-zero.
Minus times L inverse U, no, sir.
Yeah, minus time L inverse.
So 002.
002. Okay, let's. I want to do maybe because this. Yeah, this is the matrix 0 and 1. It is telling. What is the matrix you got when you 0? So you check from here. What is the mistake you have done? That's what I would say.
Yes, sir. This is correct, sir.
Which is correct?
Sir, I, sir, I have not divided by sir determinant of L, sir.
Okay, okay, okay. I see, I see. So
Which is true,
determinant
sir.
here.
Yes, sir. Which is true, sir.
Yes, the determinant also you have to divide by
Yes, sir.
the last one we did that last one there.
Sir, now this is sir clear, sir.
Clear, right?
Yes, sir.
Okay, okay, great to know. So okay, so I think then this type of questions are now clear. Also, you are telling, and we are also done with this. If any
Yes,
other
sir.
type, this type of question you get, you can solve it. I'll move to the next part. I think I would say this is the next part of the talk of the session, which is finding here. Let's say you have to find the root of this type of equation. So here you can ask that why this type of you can use that formula, right? You have this x equal to minus b plus minus square root of b square minus 4ac over 2, and you can find out. But this case it is easy, but there can be the cases where you have like x to the 4 and all type of very difficult type of, or let's say you have like e to the power 10x or some such things. I mean, I cannot precisely say this is 10x, but this type of weird function, when you have those, then it's very difficult to find out the root, okay, of that equation. I mean, e to the 10x equal to 1, let's say, some such type of things. So then it is very difficult to find out the root. So by doing the simple example, mainly we are trying to know how we will use for the difficult one. Okay, but in this course maybe you won't get those. We will be having this type of easy one, but you can verify also how much it is. Like first it is conversing. All these things you can get to know, right? So, so now what I'm saying that now to choose the interval between 4 to 5, in which the root of the uh, function this lies. Okay. When
Sir,
you,
FA into FB must be less than 0.
sorry.
Sir, if root if a root of f lies between the interval AB, sir,
Yes.
then it must change sign, sir. Means FA
True.
times FB is less than 0.
No, tell me precisely. Okay. Let me write. So what you are telling? If you have a function f, if you have a function f,
And sir,
it has a root c.
no. Yes, sir, you can, sir. But it may have, sir, multiple roots, sir, because this is
Oh,
called.
let's say a root. That's not a
Yes.
problem, right? Because there can be
Okay.
another. Belongs to a to b. Huh.
No, sir. I am, sir, telling you, sir, that if FA times FB is less than 0, then one root of f must lie
Exactly.
in closed
Exactly.
interval AB, sir.
That's why I was asking you. It's not the
Yes.
other way. Okay. Other way is not true. Because you
Sir.
take like this. Okay. Function. Let's say one function. You have, let's say a. This is b. What is fa? Fa is positive. Fb is also positive. Right? It's not changing the sign, but still it has a root here.
Yes, sir.
But the other way is always true. If it's changing sign, so and it's a continuous function. Of course, it has to be continuous function. Okay. Otherwise, what is the function? A function will be like, let's say, like this and this, right?
Yes.
So it is changing the sign. At it is b, at it is a,
At A it is, let's say, -1, at B it is 1, so it is changing time, as changing sign, but it is not having any root. That also. So it has to be continuous also. Anyway, for those are not, I mean, those are important, but in this one, what you need to find using is like iterative method, bisection method mainly. What is bisection method anyway? So let me give a little brief idea what I know. This is you have a function, let's say like this, and
So
in
first
the
we find, sir, an interval
yeah
where,
first
sir, yes, sir. Then
uh,
we successively, sir, bisect those interval and
yeah,
again
first
check.
of all we need to find out the interval where its sign change. So in this
Yes, sir.
interval you won't get value, so you have to take some function like this, right? The initial function I draw, that will not work. Yeah, so we bisect it and we
Yes,
see it is C, and let's say one point C. Then but root is here x naught, let's say. Now I see if where, so at C what is the value of f? This is fc. But between fc and fa, no sign change. So if you multiply fc times fa, it won't have any root. So we'll understand that it will be then c to b. So I take then next step c to b as an interval, and we bisect c to b. We don't bisect ca because we know inside this it might not have any root because it is not changing any sign, right? So that's why we take c and b as in the next step. And similarly, when we come to the next step, we let's say we get d. When we see what is fd, and we will see fd and fc, in between that it will have root because fc times fd will be positive, sorry, negative, right? And then we will keep on going like this, and we will see it will see we will see it will converge to that x naught point where root lies, right?
mm.
You understand the little bit idea what I gave?
Yes, sir.
Okay, so then we will do this one. So
Sir,
start
but
with the interval. Yes,
we have,
tell me.
sir, we need a calculator, sir, for this, na?
Calculator you need. Little bit you can do, if this one maybe it
For
might be
integer
possible.
values, we can do, sir.
Yeah, for this you need a calculator. So first, but try to understand first what is fx is given to you,
X square minus 5x plus 1.
plus 1, right? And what is the interval? 4 and 5. So you will see
4.5.
what is f4, 16 minus 20 plus
Negative.
1, 2.
Huh?
And right, 2, right? So no, not 2, not 2. 16 minus
Minus 3.
at 4 I'm doing, so 60 minus 2 minus 3, yes. And f5, 55 minus, so f5 will be 1.
4.5. 4.5.
No, f5, right?
Okay, sir.
1, right? 5 square minus 5 times 5 plus 1.
Positive. 1.
Yes. So f4 times f5 is negative. So there is one root between 4 to 5. Now I will take x1 as 4 plus 5 by 2. Right? We have to
Hmm.
divide. Then find out what is f of x1.
4.5.
That you are getting 4 by 5?
No, no, sir. I am telling that x1 is 4.5.
That I understand. So that will be f of 4.5. Whatever. So you tell me now. What is f of x1?
20.25.
Just use the calculator and tell me.
Sir, 1.
1?
Sorry.
It cannot be 1, is. Mainly you need to know either positive or negative. That's all.
Sir, negative.
Something which is negative, right?
Hmm.
So then root will be between Where to where? F5 was positive.
F5. Yes, sir. 4.5 and 5.
Exactly, 4.5 to 5. And you have to do similarly. Again, you do 4.5 plus x2 will be 4.5 plus 5 over 2. That will be 9.5 over 2.
4.825.
9.5, right? 2.75, right? What 25? It's not it. 9.5. So 2 times 4 will be 8 and 15
No,
will be
sir.
there. What no, sir? Is okay, right? This 4.75, right?
Yes, sir.
Yes. So, and you have to keep on doing what you find out if 4.75. So, if it is positive, then you take which one you will take 4.5 and 4.75.
4.75.
If it is positive, I don't know whether positive. If it is negative, if negative, you need to take which one? 5 and 4,
It will
4.7.
be, sir, negative, sir, na? Always, sir.
No. Whether
Now we
this
have no.
this
Now
value,
we have to, sir, bisect this interval, sir.
exactly. So you just bisect one of these interval, depending on this value is positive or not. This is positive or negative. This you do not know, right? It's not always negative. Who says?
Yes, sir.
So the but funda is this. So you which one is positive and which one is negative, depending on that you take the that point,
Interval.
that interval, and keep on doing. So mostly when you have in the exam, you have 1 or 2 mark question, then you don't have many steps. So mostly 5, 6 around. Usually it like that. You will get the answer. But there can be uh, there can be many more iteration if you do general any pro- some problem may take some 1,000, 2,000 like that. Yeah, I mean those are difficult to do in hand also. It will does the job.
Yes, sir.
Okay, that's okay. See that's so it is here. I think it's nice, very nicely written. We start with f4, which is negative, f5 is positive, so it will have a root. Now x1 will be 4.5, then f of 4.5 will be minus 1.25, which is less than 0. So the new interval will be, instead of 4, 5, we have 4.5 and 5. Why not 4 to 4.5? Because 4 also positive, f4 is also negative, f4.5 also is also negative. So it we cannot guarantee that it will have root, okay? So that's why we take 4.5 and 5, because f of 4.5 is less than 0 and f of 5 is positive, so it will have a solution. And we keep on doing and we get this. The third iteration itself, whatever the required solution we have. Okay?
Yes, sir.
You want to take a note of this, or I mean, just okay?
No, sir.
Okay. Anyway, this will be, I will upload also. Okay. So now, what is the fixed point iteration method after 5 iteration in initial case? Okay. You know the fixed point iteration method, you need to find out the root for the equation. Okay, I think it will be y equal to x plus 2. It's not x equal to square root. No, sorry. Yeah, I understand. Yeah, x equal to square root of x plus 2. Yeah, so when you have this, how to solve? Maybe you have x
Sir,
equal to,
xn plus 1 is equal to f of xm. We let, sir, f of x is equal to under root x plus 2.
yes, that will be that. Will be.
And then xn plus 1 is equal to f of xn.
X of n plus 1 will be
F of
f of
xn.
xn. So then you keep on doing. So x1 will be then what? Square
fx
root 1 plus
1,
2,
2,
right?
4, 2. Under root
x2,
3.
yes, so x, what will be x2? Square root
F
of
of x1.
x1 is root 3, right?
Root
Plus 2.
3 plus 2.
It will keep on going. You need to mainly find out what is x5, right? Whatever the route you will come, that will be the solution.
Yes,
That's
sir.
all. It's very easy. But the problems are many problems are there. So whether it will converge always or not, those are the many problems are there. So mainly the derivative of f, it has to be bounded. All these things
Less
are there.
than 1. There
Less than,
must exist alpha such
yes, yes,
that
less than one.
modulus of f dash x less than alpha less than 1.
Yes, yes. What is f dash x here? Fx is
1
square
by
plus
under
2.
root x plus 2.
So f dash x will be 1 over square root of x plus 2, right? So this is
2
always
is,
less than 1, right?
so 2 is
That's all.
there, sir.
2
1
is
by
also
2.
1 by
Yes.
2 also will be there, right? So this one will always be less than 1, right? If I'm correct.
Yes,
So
sir.
x is positive, of course. Otherwise, I mean, x is greater than minus 2. Otherwise, this won't exist even. So that's a thing is less than 1, x is positive, let's say. So then it will always converge. But
Why
otherwise,
x less than, why sir x greater than 0, sir?
sorry?
Why x greater than 0, sir?
I mean, what do you want? X is greater than
So why
what?
you have written x greater than 0?
Yeah, because then what you see, x greater than 0 means x plus 2 will be greater than 2, right?
Mm.
And square root of x plus 2 will be greater than square root of 2. So 1 over square root of x plus 2 will be greater than 1 over root 2. And you multiply by 1 over 2, this will be 1 over 2 root 2, which is less than 1. I mean, I took x greater than 0. You can take x greater than minus 1 also, you can take. To make sense of f dash x is less than 1,
Yes,
right?
sir.
But if you take fx, sorry, x is greater than just minus 2, so that won't always be less than 1, right?
Why,
Right?
sir?
Okay, why? So you take minus 2, sorry, minus 2 is x is greater than minus 2,
Then it
right?
will work, sir.
No, why I'm saying, let me check it. So x is greater than minus 2, right? So x can, you take one value, what will be that? Minus 1 plus no, minus 2 plus, that's minus 2 plus 1 over, let's say, 100, right? That is strictly greater than minus 2, right? X greater than minus 2 means x can be minus 2 plus 1 over 100.
So there is a plus 2, sir.
That's okay, that I will add it later.
Okay.
X, I mean, let's say x naught, 1 x naught. We can take 1 x naught like this, right?
Yes, sir.
So then what will be f prime at x naught? That is 1
1,
over 2 times x naught plus 2, right? Which is square root of 1 over 100.
10. It will come out will be there.
10. So what is that? This 5.
Yes, sir.
Is it greater than 1? That's why it's
No.
less than 1.
Yes.
Not, right? So that's why I was telling. You understand why I took some x greater than 0, not minus 2. You can take minus 1 also, but minus 2 should not be the one, because f prime x won't be less than 1 in that case, because you will see at minus 2 it blows up, so the derivative also will not be bounded mostly usually in this type of thing. So
Yes,
that's
sir.
okay.
Okay, sir.
Yeah, yeah. So that's why you will see initial case also won't be near minus 2. It is a, in this case is 1, and it won't be minus 2 near. So then it is difficult. Okay, so that was easy thing, and then it is here. So use the recurrent solution for the Newton-Raphson method and find the recurrent solution for the function fx equal to x to the 4 minus 2x using the Newton-Raphson method. Well, you know the Newton-Raphson method. I mean, what
Yes,
is the
sir.
formula? X of n plus 1 equal to xn minus f
Xn
prime
minus fx upon f dash xn.
f prime xn over f of xn, right?
Yes, sir.
Okay. then it will be 4x cube minus 2 will be f prime. Okay, 4x cube minus 2, and then it will be, okay, so xn plus 1 should be xn minus f prime xn over f of xn, and then in this case xn minus f prime xn will be 4xn cube minus 2 over what is f of x, and now we have f of xn, x to the power 4 minus
The first option.
sorry, I wrote the wrong formula, right?
Xn cube minus 2, sir. So numerator should be, sir, fxn, and denominator should be f dash xn.
So now I will write correctly. This is correct, right? Now
Yes, sir.
f of xn over f prime xn is, that is true. So then what will be there? So x n to the power 4 minus 2xn over 4xn cube minus 2. So it will be, whole thing will be 3xn cube over 4xn cube minus 2. Sorry, for 3xn to the power 4. 3xn to the power 4, 4xn cube minus 2. First option, right?
Right, sir.
Yes, first option. Yeah, also you have to know that this f prime xn is not equal to 0 for Newton-Raphson method. Okay. Now, one problem mainly we are doing that for Newton-Raphson method, for second method, and all these things. Okay, so second method also, you remember that or no? Second method also it will go like this: x n plus fx is given, x n plus 1 will be, okay, x n plus 1 will be xn minus that f prime xn also you take discrete form mainly, that's all. I mean, what was your Newton-Raphson method? X n plus 1 is equal to x, sorry, n plus 1 xn minus f of xn over f prime xn, right? So this f prime xn also, I mean, in a discrete way, f prime xn can be written as f of xn minus f of xn minus 1 over xn minus 1, this type of, I mean, approximately, most probably that will be the thing. Yes, that's correct, right? I mean, as an approximation you can think like this, at least if you cannot, I mean, as xn plus 1 converts to xn, then this will be equal to this, otherwise it is, you can take a approximation. Then xn plus 1 will be equal to xn minus f of xn minus f of xn minus 1 over xn minus x of n minus 1 times f of xn, right? So that is the second method. Now we can ask why you have taken here xn minus 1, why not xn plus 1? So that will make life much difficult, because that will be an implicit type of iteration, right? This is explicit iteration. Knowing you know xn and xn minus 1, you can update xn plus 1. But if you have done this approximation, f prime approximation as n plus 1, then you need again another some other very difficult, it will be very difficult to find xn plus 1.
Sir,
Yes.
sir, this difference term is, sir, not correct, sir.
Okay, I understand. So what I am telling. So
xn
this
minus
will
xn minus 1 must be, sir, in numerator.
other, I mean, whatever is using this, whatever you get, that will be xn minus xn minus 1, I guess, right? This one.
Yes.
F of xn minus 1. But you understand what is the main thing, what I was telling, you know the this Newton-Raphson method, sorry, not Newton-Raphson method, Newton-Raphson formula, Newton-Raphson method, then you can just substitute by this derivative and then you get second method. That is the
Yes.
main thing I was trying to say. And then I made mistake, of course, that is true, but that you can just check it and just change it. But that is the second method, that's all. So you will see this when they what they want x1. So x1 then will be x0, which is given minus, wait, okay, no, it's not asking. Yeah, that's why you need x0 and x1. X0 and
X2,
x1 you
sir.
need. Yeah, x0 and x1, then you can find out x2. So x2 will be x1 minus x0 over f of x1 minus f of x0 times f of x1. That's all. That is 1. So they are asking after 2 iteration. So this is first iteration, then you do the x3. Yeah, see that then you do x3. Whatever you get, that will be the answer. You start with x0 and x1 given, you compute x2, that is 0.25, and then you evaluate this one because it is needed for this. Then x3 will be again, you know, this x2 you know 0.25 minus x2 minus x1 is 1. So x2 minus x1 will be 0.25 minus 1. 0.25 minus 1 over f of x2 is minus 0.2344 minus f of x1 will be minus plus 3, right, times f of x2. F of x2 will be again negative of minus 0.23. You just use calculator and find out the answer. Is it okay?
Yes, sir.
Yeah, these are easier. Just uh, solve the question, you will understand. Okay, so you have any doubt other than that?
No, sir.
Okay, so hope you liked it, and we'll then meet again in the next weekend. These are some books and references. Thank you for your attention. We'll meet in the next weekend. Okay,
Okay,
and
sir.
today I'll be like, but we are ending it early, but all the things are covered. Whatever the things we wanted, as many people are not here, only one you were here, so it was easy also to finish it early. But hopefully, all of you will be watching in YouTube, and let me know if you have any doubt in the comment box or in panel session, wherever you want. I will meet in the next class. If you have any doubt, you come up with the doubt from this class. Okay. Okay
Okay,
then.
sir. Thank you.
Yeah. See you. Welcome.